Okay, everyone, welcome back. Now, this is not the crazy example I was talking about. This is an easier one. This is just to lead you into it. So, let's look at this. First off, we have an axial load that's applied to the ends of the bar. And one thing I hear from a lot of people is like, well, if you have a force on both ends, then is the load that anything feels in here 2p or is it 1p? My answer to you is this. We're always going to have to draw a free body diagram, and wherever we're looking at this, we're going to cut it. When we cut it, we only get to keep half of it. So I'm going to get rid of this half right here, and I can redraw this. Beautiful. Okay. And so I've got P here. Well, then what does my internal force have to equal? It has to be P. So it won't be 2P, it'll just be P. Whatever you see pulling on both ends, it's just going to be that same force in the middle. And that's very easy to see if you use your sum of the forces in the x direction after you've drawn a free body diagram. So don't forget to do that. Okay, now with that in mind, it wants you to find the elongation of segment 2 and the normal strain in segment 1 of the bar. And is the normal strain in this section going to be the same as this section? That's an interesting question, which I hope you'll find out soon. So, go forth, try it out on your own, and then come back if you get stuck, or come back either way. I'm always happy to see you, metaphorically, because this is a video. And we'll continue doing it together. So, 3, 2, 1, and you're back. You did it. You are amazing. You're like, wow, how did I do that so quickly? Well, you did it so quickly because of the magic of being able to pause a video, But, I'm not going to hold that against you. So, let's jump into it together. And one other thing here, I didn't actually read this, sorry. It says that the total elongation of the bar between joints A and C is going to be 0.15 inches. That's between here and here. It says in segment 2, the normal strain is measured as 1300 micro inch per inch, or micro strains, we could say. Okay, so that's for here. Cool. Now let's jump into this and see if we can't solve it. Okay, now from the definition of normal strain, the elongation in segment 2 can be computed like follows. It told us what the strain was, and we also know what the original length was. Since strain is unitless, 1300 times 10 to the negative 6, I can just put it in there and multiply it across. And what I will get is that the elongation is 0.1170 inches. Now, as a note, if you're really getting kind of frustrated with this whole, strain, but we don't, we call it strains, but there's actually not a unit. It's the exact same thing as radians. If you have any equation that uses radians, like a degree in radians isn't a unit. When you multiply it by something else, it disappears. Like, honestly, if you want to find the length of an arc of a circle, the circumference is 2 pi r. Well, that 2 pi is radians. That's 2 pi radians, because you went all the way around. But for any other arc, like let's say for half of a circle, well, I would just put in what that angle is in radians. I can even rewrite it. Well, the circumference of a little arc is equal to theta r. Now I would put in, theta in 180 degrees in radians is pi times r, and the radians just disappears. It doesn't exist because it's not really a unit. So it's very similar to that. It just makes it easier to talk about things when we have something to go with it, and we're not just spouting off numbers. Okay, so we found the elongation there. They also told us that the combined elongations of segments 1 and 2 was given as 0.15 inches. So if this is the elongation of one of those sections, we should be able to figure out the elongation of the second section, or I guess the first section in this case. So we could add our two together, but we're just going to solve for the elongation of the first section. We know what the total elongation is. We know what the second elongation is now, and we solve and get it. It's 0.033 inches. Okay, we've got an elongation. That's good. We also know what the original length was. So using our normal strain equation, which is strain is equal to elongation over original length. So this is usually whatever is shown in the figure. If it doesn't say specifically that this length is after it has been stretched, you consider it to be the original length. And then from that we get the strain, which interestingly enough, if you look at this, it's 825 inches per inch. So even though they're made of the same material, you see that the strains are not the same in both. Now, You're like, well, one was way longer than the other, so that changes things, right? It doesn't, because we normalize by length. Like, so the length of the bar doesn't matter. So something to do with that cross-section changed how it was elongated. So the wider cross-section elongated less. Okay? The wider cross-section elongated less under the same load. Interesting. Fun stuff. Okay, so I believe that is everything for this example. Next time we're going into a very difficult group problem. So one, it's going to be a longer video, so be prepared for that. And two, please watch it a couple times. Make sure you can work through it. The steps are always not necessarily as straightforward as you might like, but hopefully you'll see at least the gist of how we do it. And if you really have any questions, just bring them to class and we will do it together. Okay, so with all that, we're done here. And I'll see you all next time. Bye-bye.